Thank you. Thanks for coming. As you heard, my name is Col Chapa, Lieutenant Colonel, U.S. Air Force. I have the privilege to serve as the Department of the Air Force Chief Responsible AI Ethics Officer. When I say Department of the Air Force, I probably sound like your friend who insists on saying the Ohio State University. It's because we are now one department with two services. So because our office is at the department level, we care about both the Air Force and the Space Force. And of course, my job, Chief Responsible AI Ethics Officer, is in the office of the Chief Data and AI Officer. So I work for Miss Eileen Vadrine. And we're privileged to participate with you in this event. I'm going to talk about how we can sort of translate lessons learned in AI ethics from industry and commercial and academia into the air and space forces. But before I do that, I have a very important question that I would like to ask you. What do a large language model and an Air Force pilot in the bar have in common? Large language model and an Air Force pilot in the bar. They both have a lot to say, but it's probably not all true. When we talk about AI ethics in the military, there's a little bit of a linguistic problem that we've created for ourselves. In 2020, the Department of Defense adopted AI ethical principles. I'll talk more about those in detail later. But we were perfectly content in 2020 to call them ethical principles. And then in 2021, the Department of Defense said, we might want to kind of step back from that term ethical, because we in government, sometimes when we hear ethical, what we think is compliance. Right? I was invited to speak at this conference. I had to get ethics approval from the lawyers to make sure that I wasn't accepting a gift that I shouldn't accept as a government official. Right? So ethics within the government starts to feel like a checklist. And what the DoD, the Joint Artificial Intelligence Center, wanted to signal is that AI ethics is a lot broader than that. There's a lot more work to do here than just check a box. So they started using the term responsible AI in lieu of ethical AI. And then in their kind of what is their landmark publication so far, last June, they published a document called the Responsible AI Strategy and Implementation Pathway. And right at the top of that document, there's a quote from Secretary of Defense Austin that says, "This is responsible AI, and it's the only kind of AI that we do." Well, now hold on a second. If responsible AI is the same as ethical AI, and if all of our AI is responsible AI, I think we can pack it up and go home, right? Job done. And so what I want to stress to you is I don't think that's what Secretary Austin had in mind. I think he's giving us a target to aim at, right? This is an aspirational claim that when we develop AI within the DoD, we need to ensure that it is responsible AI. So I use the terms ethical AI and responsible AI interchangeably. There's a second linguistic challenge that people in this room will probably be familiar with, and that is that AI is a pretty big place, right? So when we talk about AI ethics, what really are we talking about? The practitioners in the Air Force, the people who have been doing this for a long time, are always very quick to point out to me that AI has a long history, definitely longer than the last 10 years or so, in machine learning and deep learning. So when I talk about AI ethics, I'm really talking about machine learning and deep learning, and I want to show you why that is. This is just Google Ngram data. I know the text is small. Don't worry if you can't read it. I'll walk you through it. You can do this for yourself if you want to. Google digitized a bunch of books beginning in 1800, and so you can query those digitized books and see and compare the prevalence of different search terms. So my search terms here are artificial intelligence, expert systems, machine learning, and AI ethics. And I love this chart for two reasons. First of all, that big spike right in the middle, that is what some people call the second AI spring in the 80s and 90s. The first AI spring was 1960s, theoretical for the most part, not a lot of commercial applications. Second AI spring, we get real commercial AI. It was a big deal. And notice how tightly correlated the green line, which is artificial intelligence, is with that orange-colored line, which is expert systems. The AI in the 80s and 90s was expert systems. That's what AI meant. Okay, now let's fast forward. Look, about 2015 is when it starts to pop off there on the right side of the chart. The blue color, that's machine learning, and the black line at the bottom, that's AI ethics. As machine learning kicks off after 2012, we see this commensurate increase in references to AI ethics. Notice, though, that there's no commensurate increase during the second AI spring. Right? So what I want to submit to you is that the field of AI ethics as an academic discipline is in response to developments in machine learning, not in response to other kinds of AI, what we might now call legacy AI or good old-fashioned AI. So when I talk about AI ethics, I'm talking about machine learning, deep learning. All right, so why does machine learning raise these novel ethical questions? Well, because the difference between expert systems and machine learning is that in expert systems, we were talking about deterministic if-then logic trees. It doesn't mean the system never fails, but it means when the system fails, the operator is probably in a pretty good position to understand the failure. And in machine learning, what we're asking the algorithm to do is infer inferences, to identify inferences in the data that we humans might not be able to identify on our own. Right? We're essentially asking it to give me something new that I can't see by myself. And because it's doing that differently from the way that a human thinks, sometimes it comes up with weird and surprising answers, and sometimes those answers can be ethically loaded. So I like to think about this in terms of goat path solutions. We're asking machine learning to give us goat path solutions. I don't know if this is what comes to mind for you, but for me, I think of the Spartans at Thermopylae, right? Ancient Greece, ancient Persia. Persia is toppling the Greek city-states one at a time. Sparta is one of the last remaining city-states. They are known for their military acumen. They conduct this kind of strategic retreat where they have all of the civilians and most of the soldiers retreat to a different location, and they send the famed 300 to defend this narrow pass at Thermopylae. They know that the Persians outnumber them, but they have the strategic high ground, right? So they've got a fighting chance. Well, there's a traitor among them, and a traitor among the Spartans found a goat path around the mountain. And he tells Xerxes and the Persians about this goat path. The Persians are able to take up a position in front of and behind the Spartans, and the rest, as they say, is history. No one is saying that the goats are smarter than humans. No one is saying that the goats are better tacticians than the Spartans or better strategists than the Persians. But the goats, through some combination of goat hunger and goat brains and goat instinct, were able to infer something important from the operational data that the humans wouldn't have gotten on their own. That's what we use machine learning for. That's why it's valuable, but that's also why it can give us surprising results. I'm not going to walk through all the cases. You read the news. You've heard them all. Generally, when we hear about AI ethics issues in what I usually call the domestic environment, the kind of commercial academic environment, non-military stuff, we're generally talking about an unjust distribution of goods and harms on the basis of some unjust category like race, gender, income, mobility, et cetera, right? So the outcome of these AI systems is that it disenfranchises some group or other. The question that we should be asking ourselves, that I in my professional life have to ask myself is, what does any of that have to do with our operational use cases in the US military? So just as in the kind of domestic commercial environment, right, if an AI tool, a machine learning tool, produces a result that's biased on the basis of race, for example, we would say that's morally bad. That violates a principle that we as a society hold dear. Similarly, we in the military also have principles that are very important to us. They're not always the same, right? They're specific to our operating environment. So I mentioned the AI ethics principles. Our AI systems have to be responsible, equitable, traceable, reliable, and governable. We also can take best practices from industry and academia. I'm referencing here an excellent paper by Helen Toner and Tim Rudner on AI safety. It's really a series of 4 papers. They're not talking about military stuff, but the way they describe challenges to data robustness or specification, right? Aligning the specified task with the actual task. We can take those lessons learned and help us do better in the military context. And then we also have specific principles that are relevant to us as members of the profession of arms. The just war tradition or just war theory requires, for instance, that in combat our actions be discriminate, proportionate, and necessary, right? So we need to make sure that our AI systems meet these principles, and there's probably a bunch of other stuff. Up until very recently, kind of right at this moment, I think it's starting to shift. We've had this issue in the literature where there's this big, vibrant, robust literature on the ethics of AI in that domestic kind of commercial context that I talked about. But as soon as you cross the line to talk about the ethics of military AI, that entire discussion has been dominated by lethal autonomous weapon systems. Lethal autonomous weapon systems raise important ethical questions. I'm all for it. Let's get in there and hash those out. But there is an entire world of AI applications in the military context that aren't lethal autonomous weapon systems. And the literature is I feel like we're just now getting some traction where people are starting to ask those questions. So I anticipate that over the next several years, we will identify sort of new principles, new sources of information and standards that we need to care about. I mentioned the DoD's responsible AI strategy and implementation pathway. I pulled this graphic from that document. It's public facing. You can download it if you want. The graphic gives us the impression that what we're after is trust. I would add a little nuance and say that what we're after is something like calibrated trust, right? I don't want warfighters to trust the system too much, but I also don't want them to trust it not enough, right? I want their trust in the system to match the system performance. The other thing I want to highlight to you is that they in the document, they sort of call out to all these strategic level guidance documents. They put the law of armed conflict up there at the top. That's important, right? We are going to submit to the laws of armed conflict. We have statutory and treaty obligations to do that. But notice that they put just war theory in there second. And to me as an ethicist, this is very important, that the DoD is signaling that we care about the law and we also care about the ethics, and we're going to do both. Okay, so if the open question is, what does all that stuff about race and gender bias in AI outcomes, what does that have to do with the military context? I think the best way to ask this question, to start to address this question, is to distinguish between causes and effects. right? So if you look at a case like, Amazon's hiring tool, somewhere around 2016, I'm sure you're familiar with the case, they had 10 years of historical hiring data. They said, hey, I can train an ML model on that, and so they did. And of course, the ML model ended up being extremely biased against women. And when they sort of did the autopsy to figure out why, it's because the 10 years of hiring data was also, objectively speaking, biased against women in the sense that they hired more men in that 10-year period than women. And so as the tool does the feature extraction step, it's identifying which patterns of variables in the data are correlated with the label. They identified, for instance, the possessive noun women's as correlated with not getting a job, right? Which means if your resume says something like women's college or women's engineering organization, this tool is going to penalize that resume, right? Okay, so the outcome, the thing on the right-hand side of the screen, is an unjust distribution based on gender. What's happening on the right side of the screen is something like a robustness failure in the data, right? Insufficient data to be able to get the outcome that they're after. What I think we should be able to do here is trace all of those cases from industry and academia back to the causes, and then ask some hard questions about, okay, if we had those same kinds of technical limitations, those same kinds of causes in the military environment, and we trace that out to the effect, what would that look like? It's not going to look like bias based on race and gender and mobility and income. It's going to look like identifying the wrong targets, right? It's going to look like operational failures that are also ethics failures. And I think that's the work that we have ahead of us. I want to give you 3 examples. The first 2 are squarely in the AI ethics category. The third one might be more AI safety. These are notional, but it's just a way to start thinking about how we do this work of taking the lessons from industry and academia and applying them to the military. Here's a plausible thing the Air Force and Space Force might care about. Maybe I want to have a computer vision algorithm that can identify Chinese 5th-generation fighters. That seems like a thing the Air Force might want to do. And I probably need to be able to distinguish between Chinese 5th-generation fighters, like the J-20, and US and coalition allied 5th-generation fighters, like the F-35. Right? So maybe I get this computer vision algorithm and I start to think, all right, I need a bunch of data, I need imagery data, it's probably going to be labeled data, right? Human labeled data. So I'm probably going to need a bunch of images of J-20s and a bunch of images of F-35s. But I have to be really careful here, right? Because in the example I just mentioned, the feature extraction step can be opaque to the developers, right? So what features is my computer vision algorithm going to identify to associate with the label, the human label J-20? If I'm not careful, it might identify features like those canards. You see those canards forward of the main wing? Those canards are control surfaces forward of the main wing that add maneuverability. The F-35 doesn't have canards. In fact, no fighter aircraft in the United States military has canards. So if I were to build this robust data set that has all the Chinese fighters and all the US fighters, and I train my model against that, I might end up creating a specification failure, right? Where I wanted my model to do was identify J-20s, and what it actually does is identify canards. That's a big problem for me, because I have some really close friends like the Brits that fly the Royal Air Force Typhoon, right? That's an airplane that does have canards. So I might put myself in a situation where the same kind of data robustness challenge, right, that leads to a failure of specification, that in the industry case might lead to an unjust distribution based on race, gender, et cetera. In my world, that might lead me to identifying the wrong targets, right? It might lead me to, if it came down to a conflict, to shooting at my friends. That's an operational failure as well as an ethical failure. Example number 2, this really happened. This is a true story. I think it ends up being a good news story. You're probably familiar with Project Maven. That was DoD's first big machine learning effort somewhere in the neighborhood of 2017. There was a kerfuffle between DoD and Google because Google engineers were unhappy that Google was a subcontract to this project. They have ironed all that out, and Google now is supporting DoD once again. But that's why Maven became famous. Maven is a computer vision tool that's trained initially on Reaper video from Afghanistan. Right, so we've got mountains and mountains of Reaper video, and we're training this object classification tool to identify different classes of objects, one of which is vehicles. So as they're training this model and testing it against the original data set, it's performing extremely well at identifying vehicles. I don't know the F1 score, but it's doing pretty well. And then they ran that same model in a test and evaluation scenario on video from the United States outside of New Orleans, and it performed abysmally, like a 10% success rate at identifying vehicles. If any of you have been to Afghanistan, you might know what color most vehicles are in Afghanistan. They're all white. All the vehicles are white, right? So the Maven team tried to create a vehicle identifier and inadvertently created a white vehicle identifier. And when they ran that against the US data set, which has our whole rainbow of car colors, all it could do is identify the white vehicles, right? So again, failure of specification. In the industry case, that might lead to some unjust distribution. In my world, that might lead to identifying the wrong targets. Third, this one's a little bit different, but I did want to use it. I did want to get to a reinforcement learning example. In the military, we do something called COA development, course of action development. Traditionally, this is teams of strategists that develop several, maybe 3, maybe 5 courses of action. They identify the benefits and costs of each one. They submit those to the commander, and then the commander makes a decision as to which one to execute. We are reaching a point at which our modeling and simulation environments are so good, are so precise, that we might be able to do COA development using a reinforcement learning model in a modern sim environment, right? So what if I just simulate the entire operational environment, run this reinforcement learning algorithm, train it in that modern sim environment, and have it spit out to me what is the best outcome? There's a limitation with doing that. In the academic literature, a bunch of researchers taught an AI agent to play Atari games using this reinforcement learning in a modern sim environment. I'm not old enough to remember the game Q*bert. My parents tell me stories. But in Q*bert, you're supposed to move your little guy around and change the color of the cubes to whatever the target color is for that level, and then you get a bunch of points. Well, the objective function that they gave their algorithm was to maximize points. And so when they ran this thing, they found that it jumped in a series of what looked like random jumps. It didn't look like it was trying to achieve the goal of the level. But that series of pseudo-random jumps triggered a glitch in the game that gave it infinity points. So if you watch this video to the end, it gets up to 99, 999, then it starts over at 0 and goes up again, right? So this agent was able to see so many iterations of the game, so many board configurations, if you will, that it identified a glitch that no one in the history of Atari knew existed. And the people who wrote the article ended up chasing down the original developer and asked him, like, did you put that there as kind of an Easter egg? And he said, no, I had no idea that was there. It was just an accident, right? That's a real problem for me if I'm going to do reinforcement learning enabled COA development, right? Because reinforcement learning enabled COA development works perfectly as long as the modern sim environment reflects the real world to 100% accuracy. And I have some bad news. No modern sim environment is going to reflect the real world to 100% accuracy, right? So if my machine learning model is essentially exploiting glitches in the modern sim environment, when it spits out this magical, this cure-all, this is the COA that's going to, the COA to rule them all, I have to be really concerned about that, right? Because it might just be exploiting glitches that I didn't know about. So those are the 3 examples. I have to say something about generative AI because it's the topic du jour. It's what everybody wants to talk about. I could talk about how generative AI essentially takes all these challenges of machine learning and deep learning and multiplies them by n, right? Because the models are even bigger, the networks are even deeper, the relationship between input and output is even more opaque. But I don't want to do that. Instead, I want to talk about how we might use these tools in a way that's wise and prudent in the Department of the Air Force. So the way I see it, there are 2 things we can use generative AI for. I have in mind large language models, I will admit, but I think you could extrapolate this to other generative AI. I can either use them to give me efficiencies in work that I already know how to do, right? I have used this myself. I write sometimes. That Amazon case I gave you, I have written that paragraph 100 times. I don't need to write it again. So I can just ask a large language model to write that paragraph for me, right? I know the dates. I know the sources. I'm going to know if it gets it wrong. So I can very quickly check that it got it right, right? So that's knowledge I already have. I'm just using it for the generative function. There are times that people want to use generative AI to find new information about the world, right? Maybe in aggregating all of this interwebs data, right? Maybe this model has learned something about the universe that we don't already know. I know it sounds like that's a bad idea, but people are already trying to do that. So, for instance, you read the article about the legal associate who not only had ChatGPT write the brief, and the brief gave citations to case law that didn't exist. And then he checked it, and by checking it, I mean he asked ChatGPT, do those cases really exist? And ChatGPT was like, yep. So he filed it, right? So he's trying to get new information about the world. He doesn't know what the relevant case law is to this case. He wants to use generative AI to do it. So what I want to suggest to you is those are the 2 things we can do. And I put the human in the center here because I think the human belongs at the center, right? So I'm going to use AI either to give me efficiencies or to give me new information about the world. And then I need to verify that information. And I think that I didn't write this, I didn't come up with this. This is something smarter people than I have said. But the best way to think about this is that ideal use cases for generative AI are hard to do, measured in whatever, time, money, whatever, right? They're hard to do, but they're easy to verify. So a go-to example is code, right? If you want to use generative AI to write your code for you, it might make mistakes, but determining whether it made mistakes is really easy, right? Because you run the code, and if it doesn't work, then there's a mistake, right? Whereas if I want to ask generative AI, hey, tell me what Putin's going to do in Ukraine tomorrow. I have no way to verify the answer to that question. It might be right, but I have no way to determine that. And so what I think we in our institution in the profession of arms need to do over the next several years is build up institutional guardrails to say, how do we do the hard work, the new knowledge problems? How do we get the most out of these systems that we can while building in safeguards to be able to verify the hard questions? I think that's what lays ahead of us. Just 2 slides to close. There's 2 different questions here on the slide, and they're very, very different. The first question is the question that a lot of developers have to ask themselves. How do I ensure that this system that I'm creating is responsibly done? That's not an easy question to answer, but it's a whole lot easier than the second one, which is how do I ensure that every system that this 600,000 person military organization creates is responsible? That's the task that we have ahead of us, and it's hard work, and we appreciate your help. The second thing I would say is that this work requires some creative thinking. It requires critical thinking, but that gets enough emphasis. I want to emphasize that it requires creative thinking. The kind of work we've been doing here in the last 20 minutes is to say, what of the lessons learned from industry and academia can I apply to military use cases, and what does that application look like? I think that's also work that remains for us over the next couple of years.